Hello! Today we are going to be solving the B problem using repetitive nearest neighbor and cheapest link. Now if you don't know how to use repetitive nearest neighbor and cheapest link, don't worry because I'm going to teach you how. In the bee problem, we have to help Mary the bee reach all the flowers and get back to her hive. Here's her hive down here at H. So we're going to start with repetitive nearest neighbor. So we have to start and end at H, but that doesn't mean that we only find the repetitive or the nearest neighbor from H. So the nearest neighbor is where you find your point and then you go to the point that has like the least cost on the line. So for this one, our options are 4, 9, 6, 12, and 8. So our nearest neighbor would be 4, H to D. So what we have to do is we have to do that, but for all of these ones, and then add them all up and take the costs down and then readjust for starting here. So the nearest neighbor from H we established was to D at 4 because our options are we could go to H to S, H to A, H to P, or H to C. And our options there are 8, 12, 6, 9, and 4. And since our cheapest is 4, we're going to do H, D. Now, what I like to do to keep track of it is I like to put my number up at the top there, and then once I'm all done, I have all my numbers and I can add them all together. So I have H to D. Now from D, since we've already traveled H, we can't go back to H. So H to D, so now from D, our neighbors are 2, 3, 8, and 6. So our nearest is 2, so we're going to go from D to S, and then we're going to write our little 2 up there so that we can keep track of it. So S, we still have to go to A, P, and C. We can't go to D or to A. So to A, P, and C, our options are 10, 6, and 7. So our nearest is 6, so we're going to go to P. Oops, that's a 6. P. So now from P, we have to go to A and C. So 5 or 4. 4 is the best. So C, 4. Then C, we have to go to A, because if we go straight to H, then we didn't visit A at all. And we can't go back to H and then up to A because that would not be effective. So C to A is 2. Then A to H is 6. Oops, I didn't put an H. H, 6. So I'm going to leave those for now and do all of my math at the end. So next we're going to start from, we're just going to go around in a circle. So we're going to do D. So I'm going to move down one. So from D, we have 2, 3, 8, 6, or 4. So 2 is obviously our cheapest. So now we're at S, and we can go to 9, 7, 6, or 10. So 6 is our lowest, so we're going to go 6. 6 to Poppy. P, so now we have to visit A, C, and H. So from P, A is 5, C is 4, H is 12. P to C is the lowest at 4, so we're going to do that. 4, C. Now we have to go A and H. So 8 or 2. 2 is obviously lower. Now we have to go to H because we only have 2 left, which is D and H. And since we started at D, we can't go back there without going to H. So 6, H. Now H to D, 4, D. Real quick. Okay. H to D is 4. D to So now that we've done D, we're going to do S. We have to add them all up. So we're going to start doing our math with our little numbers that we wrote down. So on this one, we have 4 plus 2 plus 6 plus 4 plus 2 plus 6. That was a lot of 4s, 2s, and 6s. So this one's 24. That is the feet that the bee has to travel. So we have 3 paths that have the least amount of mileage for a little bee. They're not miles, they're feet, but for her it's practically a mile. So we can pick any of these ones, but we have to start and end at H. Okay, so since this one starts with H, we're not going to use it just because I want to show you how to make the smallest one start at H. So we're going to pretend that that one isn't the lowest one. We're not going to use it. We're going to use, so we have to make it start and end at H. This one starts at A. So we have to find where H is and continue the pattern from there. So this one, H is right here. So we're going to start it at H. Then the next one is A. Then from there on, we move on, and there's another A, but we can't double it, so we're going to skip on to C. C, P, S, D, and then we're going to start back at H. And equals 24, because that's our lowest little guy. So that is the optimal tour for Mary the Bee, using repetitive nearest neighbor. But now it's time to solve it using cheapest link. Okay, so now we have to do cheapest link. And so this is the same graph, just on a separate piece of paper, because we need room, because this time we are using this pen. That way we don't get lost. So cheapest link starts out by finding the cheapest link on the whole graph. So in this case, we have 2. S to D and A to C are both 2. So we're just going to pick one to start off. S to D and A to C. So the first 2 lines never create any problems. But from there on out, there are rules. So you can't have, if there are 2 lines stemming out of one vertice, all of the other lines in that vertice, you can't use them. And then if you have a line that's going to make a mini circuit that you could just go around forever, you can't use that one either. Now that we have these 2, they don't have to connect right away, because they're going to connect in the end, so they don't have to connect at the beginning. So we're going to find the next cheapest link now. So we have, appears as if 3 from A to D is the next cheapest. So off we go, down we go. So now this has two vertices stemming from it, so we can't use that one. So we're going to highlight all of the ones that we can't use in blue. So this line, and this line. Can't use them. So we're also going to block out the numbers that go with them, just so that we know. That way we don't look at that number, think about using it. So next, the next cheapest. Looks like it's 4 over here at P. It's important. C now has 2 going out of it. So we can't use this 8 and we can't use this 7. So we're gonna give them our line of disapproval. Cover up the numbers, that way we don't look at the numbers and think about using them. Okay, so our next cheapest is 5, but we can't use 5 because that would create a circuit between A, P, and C where you could just go around forever. Give it our marker of disapproval. We also can't use AS because that would also create an A, S, and D circle where we could just go around forever. Next, S and P also has become unusable because it would create a circuit. So we can't use that one either. We're going to cross out the number that goes with it. So our options now are 6, 9, and 12. But wait, 6 isn't an option either because it would put 3 points out of A. And we don't want that, so we're going to give that the blue cross down as well. Not using that. Next, our options are S to H, P to H. So S to H is the cheapest at 9. There's only 1 line left on our graph. So we're going to take it. There's our tour. But now we have to do the math. We have to add it up. So if we're starting and ending at H, we can go H to P, which is 12. So we're going to do our little number thing again. To P is 12. Now P to C is 4. C to A is 2. A to D is 3. D to S is 2. Then S back to H is 9. Now, gotta add those numbers together. Okay, I've added them all together. It's 32. So that is the cheapest link and the cheapest, the repetitive nearest neighbor for our Marry the Bee.